Welcome back to the Awesome Agents podcast. Today we're talking about a benchmark study that's going to make a lot of developers uncomfortable.
Yeah, this one hit different for me. Alibaba researchers put 18 AI coding models through something nobody has really tested before.
So set it up for us. What do they actually do here?
They built this benchmark called SWE-CI. Instead of giving a model one bug to fix, they gave it 100 real Python code bases to maintain over time.
Over time, meaning what exactly?
Each code base spans an average of 233 days of real commit history, 71 consecutive commits. The agent has to keep fixing things as the code evolves.
So it's not a snapshot test. It's like, here's 6 months of a real project. Don't break it.
Exactly. And that changes everything because the failure mode they're catching is really specific.
What's the failure mode?
An agent fixes commit 15, but that fix quietly breaks something that worked at commit 10. It passes today's tests but damages tomorrow's code.
Okay, so how did the models do? Give me the headline number.
3/4 of the models they tested break previously working code during the evaluation, 75%.
That's bad. That's really bad.
It is. They track this with a metric called zero-regression rate. It measures how often an agent's changes don't break anything that used to pass.
And most models are failing that most of the time.
Right. The majority of models sit below a 25% zero-regression rate. That means more than 3 out of 4 iterations introduce some kind of regression.
Who actually does well here?
Claude Opus is the only model family that gets above 50% zero-regression. GLM5 shows up as a solid secondary performer. Everyone else is far behind.
Okay, so there's Claude Opus, then GLM5, then a big drop-off. What's interesting about that gap?
The paper makes an observation about it. Models within the same provider tend to cluster together in performance, which suggests training methodology is the key factor, not just raw model size.
So it's not just that Opus is bigger, it's something about how it was trained.
That's the implication. It seems to hold more awareness of the broader code-based behavior rather than treating each commit like an isolated problem.
I want to ask about the scoring system because they introduced something new here, right?
Yeah, Evo score. It's a weighted average where later iterations in the commit sequence count more than earlier ones.
Why does that matter?
Because an agent can look great on the first 20 commits, then completely fall apart by commit 60. A simple average would hide that collapse. Evo score surfaces it.
So it's penalizing agents that start strong and degrade the ones that borrow from the future.
Exactly. The agent patches the immediate failure, moves on, and 3 commits later, something breaks that nobody expected.
This feels like something developers have been sensing for a while but didn't have a number for.
That's what I think is most useful here. Everyone who's used an AI coding agent for more than a sprint or two has felt this. The code drifts, things break in weird ways.
And now there's a benchmark that quantifies it?
With real repos too, not toy examples. They started with almost 5,000 repositories and filtered down to 100, based on longevity, star count, license type, and code volume.
What are the limitations? Because there's always a catch.
Python only, that's the big one. JavaScript, TypeScript, Go, Rust, none of those are covered yet.
Which matters a lot because maintenance patterns in a big TypeScript codebase might look really different.
Right. The researchers acknowledge it. The framework aims to extend, so presumably those will come.
What's the practical takeaway for a team that's actually shipping with AI coding agents right now?
If you're using an agent for ongoing work, not just one-off fixes, this benchmark is the question you should be asking. Not just did it fix the bug, but is it accumulating debt that bites us later?
And based on this study, most agents are building up that debt fast.
Yeah, a tool that resolves today's ticket but breaks next sprint's code isn't saving time. It's deferring a bigger problem.
This is going to push more teams toward actually testing their AI tools on longitudinal maintenance tasks, not just isolated issues.
And honestly, it should push the labs too. If training methodology is what separates Claude from the pack here, that's a signal worth acting on.
All right, this one's worth reading if you're assessing AI coding tools for your team. Link to the arXiv paper is in the show notes. Thanks for being here, Maya.
Always.